Hey everyone! Today I will learn about parallel lines cut by transversals so that we can identify angles and angle relationships between them. You'll know you've got it when you can name equal and supplementary angles between parallel lines and transversals. So I brought back this picture, which we should recognize. As you can tell, we've got two angles here and we've got two here. I can tell that this one's obtuse and that this one's acute, if we remember that. So I'm going to go ahead and give you that this angle is 110 degrees. So let's say we know that that is 110 degrees. Well, these two angles, since they're on this straight line here, are going to equal 180. This is all stuff we'd already learned. So 110 plus 70 is going to give me that 180. So I found that just by doing 180 minus 110 gave me 70 degrees. Well, if we look at this picture, we also learned something about opposite angles. So we learned that these opposite angles are called vertical angles and that those are equal to each other. So if this is 70, then this one is 70. And so if this is 110, this one's 110. So those were called vertical angles again, just a reminder. So this picture we should be familiar with. Now I want you guys to look at this one. If you take a look at it, this picture is the exact same. I just made two of them. So there's one, there's the other. So again, let's pretend that this angle I'm telling you is 110 degrees. And so we know this one must be 70 degrees. Well, filling in the rest of my picture, the rest of my angles in my picture, we know that across from this is also 70. Across from this is also 110. Well, now, these two lines, this is where we're learning that if those lines are parallel lines, then I can relate these angles to these angles down here. So this 110 degree angle right here is going to be the same thing right there. So this is also 110 degrees. Now, if I'm just looking at the little angles down here, just as we did up here and over here, these two make vertical angles, so I have 110 degrees. And then using supplementary, I know that these are going to be 70 degrees. So all we did was look at our relationships from this picture and realize that if these two lines here are parallel, which is what these little arrows mean, so it means parallel lines, then we can relate these angles to these angles. So let's put that in a more general sense. So if we move our paper down, we're going to write out a more general sense of the relationships. So general angle relationships. So if we look up here again, we had 110 and 110. Those are the same. I'm going to change those and put a letter. I'm going to call them A. They're going to be angle A. So when our angles are across from each other, we've named them both A because A is equal to A. It's the same letter and it's the same angle measure, just like we learned from vertical angles. Similarly, since these are both 70, but they're not 110, it's a different angle. You can tell because obtuse and acute. I'm going to call this one angle B. So if this is angle B, then I also have angle B down here. So just like with my A angles, my B angles are also going to be equal. And just like we filled in the angles up here and on the bottom, we can use our A's and B's on the bottom as well. So I label A and B and B. So we see that A's are equal to A's, B's are equal to B's. But now I want to know what happens if we added an A and a B, that last combination we could get. Well, if we add an A and a B, if I look at this here, an A and a B are going to be just like this picture. I have A and B. And what did we learn that this is called? A straight angle. And a straight angle equals 180 degrees. So these two equal 180. So any A plus any B is equal to 180 degrees, which we say is supplementary. So this is exactly what you will need to remember when approaching these problems. By labeling your A's and B's, you can figure out what the angle relationships are. So if we slide our paper down, there are going to be some fancier names for these types of angles. We're going to talk about just generally what these words mean. So interior is what I'm going to start with, is a fancy word for inside. So all of the angles in here are interior angles. So again, these are just names to name the types of angles we have. So if I use numbers to label my angles, all of these interior angles I see are angle 3, angle 4, angle 5, and angle 6. Those are all interior. Similar to interior, we have exterior, which means outside. So my exterior angles are all the ones on the outsides. So angle 1, angle 2, angle 7, and angle 8 are exterior. Alright, a few more words here. Alternate is going to be like opposite. So alternate refers to which side of this transversal they are on. So these are our two parallel lines. Our transversal is that line that cuts through them. So that's a good little side note we should make here. This is called the transversal. So if we look at angle 1, alternate can be like angle 1, and I look at the other side of the transversal, angle 8 are going to be alternate, angle 1 and angle 8. I also have alternate on the inside, so if we pick angle 4 and the other side of the transversal makes angle 5. Alright, two more relationships here. So the opposite of alternate is when we have consecutive, so that is going to be same side. So our consecutive angles, I'm going to write that over here, are going to be like these two here when they're on the same side, or these two on the same side. So angle 3 and angle 5. And then the same side, angle 2 and angle 8. So all of these are just different examples for these names. Alright, our last one is called corresponding. So for corresponding, you want to think about the same spot. So if we look at angle 6, put a box around angle 6, the same spot angle is going to be up here. We want to look at these four. Which one's in the same spot as 6? If 6 is on the top right means angle 2. So I can write that over here. Correspond are like angle 2 and angle 6. Alright, so as long as you have at least one example for all of these vocabulary words, you are good to go. This is a lot of information right here, but it's really just a minor detail in this topic. So the chances of you seeing this on a test, probably like one question. What we are going to see the most of is this type of stuff. So the first thing we want to do for these problems, I need to identify the angle relationship and find the value of x. I assume that L is parallel to M, so that means parallel. Alright, so the first thing I want to do is just like what we have here. I always start by labeling my A's and B's. So I label A, B, and then I switch B, A. A, B, B, A. Alright, so if I want to think about what that angle relationship is called, the name, I'm looking at these two angles that I know. I can tell they're on the outside of the parallel. And then if I look at this transversal, are they on the same side of the transversal or opposite sides? Hopefully you said opposite, so we are going to call those alternate exterior angles. So that is why we want to know all those names. The other thing I want to do is solve for x. So I'm going to look at my two angles here. I have 3x plus 5 and 65. I see that 3x plus 5 is a b, and 65 is also a b. So b and b are the same letters, so I learned that those are equal. So my equation tells me to set those equal. From there we just solve it. So I subtract 5, 3x equals 60. Divide by 3, and you get x equals 20. Alright, go ahead and try this one on your own if you'd like. We are going to check it in class. Thanks for watching.